Hello there, and welcome back to the quiet drift of the sleepy ocean. Tonight, we are setting our course for one of the most enigmatic and whispered about corners of the world, a place where the map seems to blur and the horizon stretches into the infinite. We are traveling to the western part of the North Atlantic Ocean, to the region known as the Bermuda Triangle. But we are not here to solve puzzles or to stir up anxiety. We are here to observe the vastness, the history, and the deep, heavy silence of the water itself. To begin our journey, we must first understand the sheer scale of this invisible shape. The triangle is not a small, contained pocket of water, but a colossal expanse covering roughly 500,000 square miles of open ocean. It is anchored by three distinct points: the bustling tropical coast of Miami, Florida, the lush, fortified island of Puerto Rico, and the lonely, coral-fringed outpost of Bermuda. Between these 3 points lies a world of shifting blues, where the Atlantic is at its deepest and most unpredictable. As you imagine floating over this space, realize that the boundaries are not walls, but suggestions, lines drawn on paper that the ocean itself does not recognize. The water here is a dynamic, living entity, constantly moving, breathing, and changing, indifferent to the lines we draw upon it. It is a place where the sky and the sea often mirror each other in a perfect, disorienting azure, making it easy to lose track of where the air ends and the water begins. Drifting slowly toward the center of this expanse, we encounter a phenomenon that is unique to this part of the planet: a sea within a sea known as the Sargasso. Unlike every other sea on Earth, the Sargasso has no shores, no coastline, and no land to border it. It is defined entirely by ocean currents that swirl around it, trapping a vast, rotating body of water in the middle of the North Atlantic gyre. The water here is exceptionally clear, often a deep, piercing blue, with visibility stretching down hundreds of feet into the abyss. But what makes it truly dreamlike is the sargassum, a type of golden brown seaweed that floats on the surface in massive, island-like mats. For centuries, sailors looked upon these drifting forests with superstition, fearing their ships would become entangled in the thick vegetation, holding them prisoner in the calm, windless center. The silence in the Sargasso Sea is profound, a heavy stillness where the wind often dies completely, leaving sailing ships of the past to drift aimlessly for weeks under a relentless sun. It is a place of biological wonder, a nursery for eels and turtles. But to the human eye, it looks like a golden prairie resting on top of a bottomless deep, a quiet trap where time seems to slow down and the world feels suspended in amber. Cutting through this stillness, like a powerful hidden river, is the Gulf Stream, a force of nature that plays a critical role in the mysteries of the triangle. This is not just a current. It is a warm, high-velocity underwater river that flows roughly 40 miles wide and can reach speeds of 5 miles per hour, which is faster than many people walk. Originating in the Gulf of Mexico, it wraps around the tip of Florida and shoots northward through the triangle, carrying billions of tons of warm water toward Europe. The energy within the Gulf Stream is staggering, possessing more force than all the rivers of the world combined. For a ship or an aircraft in distress, this current acts as a relentless conveyor belt. If a vessel were to sink or a plane were to crash into these waters, the wreckage would not stay put. Within hours, the evidence could be swept dozens of miles away from the initial site, and within days, it could be scattered across vast distances, effectively erasing any trace of the event. The Gulf Stream is a chaotic, churning engine that wipes the slate clean, ensuring that the ocean keeps its secrets by constantly moving the pieces of the puzzle. Above this churning water, the atmosphere is just as volatile and prone to sudden, violent shifts that can catch even the most experienced traveler off guard. The Bermuda Triangle is a bowling alley for weather systems, where storms can materialize with terrifying speed. One moment, the sky is a perfect, unblemished blue, and the next, dark, anvil-headed clouds can form, unleashing what are known as microbursts. These are intense, localized columns of sinking air that hit the surface of the ocean with the impact of a bomb, spreading outward at speeds exceeding 150 miles per hour. These air bombs can create instantaneous, towering waves and flatten the water surface into a frenzy of white foam. For a pilot or a sailor, these microbursts are invisible until they strike, capable of swatting a plane out of the sky or capsizing a small boat before a distress signal can even be keyed. The weather here does not always warn you. It simply changes, turning the calm dream of the tropics into a chaotic fury, only to vanish just as quickly, leaving the sun to shine down on a violently empty patch of sea. The history of strange occurrences in this region is not a modern invention, but dates back to the very first recorded voyage across these waters by Christopher Columbus in 1492. As Columbus navigated the Santa Maria through the quiet dark of the Triangle, he kept a meticulous log of his journey, documenting the unease of his crew and the strangeness of the New World. On the night of October 11th, just before making landfall, Columbus and his men witnessed a bizarre sight that has puzzled historians for centuries. They reported seeing a great flame of fire crashing into the sea, followed by a strange light appearing in the distance. The light was described as flickering like a small wax candle, rising and falling, vanishing and reappearing. While modern science suggests this was likely a meteor streak or the distant torch of indigenous fishermen on a canoe, for the sailors of 1492, floating in the absolute void of the unknown Atlantic, it was a sign that the laws of nature were bending. It was the first note in a long symphony of unease, a recorded testament that the lights in this part of the world do not always behave as they should. Columbus also noted another peculiarity during that voyage, one that brings us to a very real and scientific feature of the Triangle: the erratic behavior of the compass. As his ships pushed further west, the crew became terrified when their compass needles began to drift away from the North Star. In the 15th century, sailors navigated by the stars, and the compass was assumed to be an infallible link to the heavens. What Columbus had encountered was the agonic line, an invisible boundary running through the Bermuda Triangle, where true north and magnetic north fall into perfect alignment. In most places on Earth, there is a variation between the two, a calculation that navigators must constantly adjust for. But in the Triangle, this variation vanishes or shifts unpredictably as you traverse the line. For a navigator relying on magnetic bearings, this can be deeply disorienting. If you fail to account for the variation as you move, you can find yourself dozens or even hundreds of miles off course, lost in a featureless expanse of blue water where every direction looks exactly the same. Beneath the surface, confusion lies a geological reality that is darker and deeper than almost anywhere else in the Atlantic. The southern boundary of the Bermuda Triangle is marked by the Puerto Rico Trench, a massive underwater canyon that plunges into the crust of the Earth. At its deepest point, the Milwaukee Deep, the ocean floor sits more than 27,000 feet below the surface. To put that in perspective, if you were to place Mount Everest into the trench, the peak would still be covered by thousands of feet of water. This is a realm of crushing pressure and eternal midnight, a place where sunlight has never touched. The topography of the Triangle's floor is not a gentle slope, but but a landscape of steep drop-offs, deep canyons, and vast, sediment-covered plains. If a ship sinks here, it does not just settle on a shallow shelf. It can tumble down into these abyssal depths, landing in a place so remote and inhospitable that recovery is technically impossible. The trench is a dark basement where gravity pulls everything down into the ultimate hiding place, wrapped in the crushing weight of 5 miles of water. One of the more fascinating geological theories proposed to explain the sudden disappearance of ships in this region involves the seabed's chemistry, specifically the presence of methane hydrates. Deep beneath the continental shelf, frozen pockets of methane gas are trapped within the icy lattice of the ocean floor. The theory suggests that seismic activity or underwater landslides could destabilize these pockets, causing them to rupture and release massive, erupting bubbles of gas. As this gas rises to the surface, it expands, turning the water into a frothy, low-density soup. Physics dictates that a ship is designed to float in water of a specific density. If the water suddenly becomes aerated and less dense, the ship can lose its buoyancy in an instant. It would not sink slowly. It would drop like a stone, swallowed by the churning white water before the crew could even realize what was happening. While this phenomenon has been proven in laboratory settings, the ocean keeps its counsel on how often the floor truly burps these gas bombs into the path of passing vessels. The surface of the triangle is also a breeding ground for rogue waves, a terrifying natural phenomenon that was once considered a myth by oceanographers. For centuries, sailors told stories of walls of water appearing out of nowhere in calm seas, only to be dismissed as tall tales. We now know that the unique geography of the Bermuda Triangle, with its swift Gulf Stream currents colliding with Atlantic storms, creates the perfect conditions for these monsters. Rogue waves are not just big waves. They are freaks of nature, sometimes reaching heights of 80 to 100 feet. They form when smaller waves synchronize, or when currents focus wave energy into a single point. Imagine a ship navigating through a standard storm, handling the 20-foot swells with rhythm and routine, when suddenly, a vertical face of water, the height of a 10-story building, rises from the darkness. The impact of such a wave is devastating, capable of snapping a steel hull in two or swamping a vessel instantly, leaving behind nothing but scattered debris and silence. One of the first major modern mysteries to cement the reputation of the Triangle occurred in 1918 with the disappearance of the USS Cyclops. This was not a small fishing boat or a fragile plane. The Cyclops was a massive Proteus-class collier of the United States Navy, a 542-foot steel beast loaded with 10,000 tons of manganese ore. She was traveling from Barbados to Baltimore, cutting through the heart of the Triangle. The ship simply vanished. There was no distress call sent, despite being equipped with a radio. No wreckage was ever found. No bodies ever washed ashore. It was as if the ocean had simply opened up and swallowed the Leviathan whole. The only trace left behind was a silence that has lasted for over a century. The loss of the Cyclops remains the single largest non-combat loss of life in US naval history. A haunting reminder that even the largest machines built by human hands are insignificant against the scale and power of the open ocean. Perhaps the most famous legend of the Bermuda Triangle, the one that truly ignited the world's imagination, is the story of Flight 19. It was a crisp, clear afternoon on December 5th, 1945, when 5 TBM Avenger torpedo bombers roared down the runway of the Naval Air Station in Fort Lauderdale. The mission was a routine training exercise known as Navigation Problem Number 1. And some triangular flight path designed to test the pilot's dead reckoning skills. The lead pilot, Lieutenant Charles Taylor, was an experienced veteran with countless hours of flight time. As the squadron flew east over the Bahamas, the weather was fair and the sea was calm. It was the definition of a standard day. But as the afternoon wore on, something strange began to happen to the perception of the pilots. The orderly world of instruments and horizons began to dissolve into confusion, transforming a simple training run into a journey into the unknown. As Flight 19 continued its patrol, the radio transmissions received by the control tower back in Florida painted a chilling picture of disorientation. Lieutenant Taylor reported that his compasses were malfunctioning, spinning wildly and offering no direction. "We don't know which way is west," he said, a statement that should have been impossible for a pilot flying over the familiar landmarks of the Florida Keys and the Bahamas. But to the pilots of Flight 19, the islands below them didn't look right. The ocean didn't look right. The visual cues they relied on seemed to have shifted or vanished. As the sun began to set, casting long shadows over the darkening water, the anxiety in their voices grew. They were flying in a world where north, south, east, and west had lost their meaning, trapped in a bubble of confusion where every direction led only to more open water. The tragedy of Flight 19 was compounded by the disappearance of the rescue plane sent to find them. As the realization set in that the 5 Avengers were lost, a PBM Mariner flying boat was dispatched with a crew of 13 to search the last known location. The Mariner was a flying fuel tank, a massive aircraft designed for long-range search and rescue. It took off into the night sky, headed toward the darkness where Flight 19 was believed to be. It was never heard from again. A merchant ship in the area reported seeing a massive fireball in the sky, suggesting the plane may have exploded mid-air, a known risk for the gas-heavy mariners. In a single night, 6 aircraft and 27 men had vanished into the triangle, leaving behind no rafts, no oil slicks, and no answers. The event solidified the idea of the triangle not just as a dangerous place, but as a place that actively resisted rescue, a hungry void that compounded tragedy with mystery. This disorientation experienced by pilots has led to the theory of electronic fog, a term coined to describe a strange meteorological and electromagnetic phenomenon reported by survivors. The most famous account comes from a pilot named Bruce Gernon, who claims that in 1970, while flying from the Bahamas to Florida, he flew into a peculiar, elliptical cloud. Unlike a normal storm cloud, this one seemed to spiral and glow. As he pushed his aircraft through the center, he described a tunnel forming in the cloud, with walls that scraped the wings of his plane. When he emerged on the other side, he found himself over Miami Beach, but he had arrived nearly 30 minutes earlier than physically possible. His electronic instruments had malfunctioned during the passage, and he felt a sensation of weightlessness. While meteorologists might describe this as a rare form of severe weather or a microburst, the story adds a layer of time distortion to the lore of the triangle, painting it as a place where the clock itself might tick at a different rhythm. If we look below the surface, near the island of Bimini, we find another puzzle that blurs the line between geology and mythology: the Bimini Road. Lying under about 20 feet of clear, turquoise water, there is a formation of limestone blocks that look suspiciously like a paved street. The stones are large, rectangular, and arranged in a straight line that stretches for nearly half a mile. Discovered in 1968, this formation immediately sparked theories that it was a remnant of the lost city of Atlantis, a road leading to a civilization that sank beneath the waves thousands of years ago. Geologists, however, offer a sleepier, more patient explanation. They identify the stones as beach rock, a natural sedimentary rock that forms rapidly along shorelines and tends to crack in uniform, rectangular patterns due to the stress of settling. Over millennia, rising sea levels submerged this ancient beach, leaving behind a road built not by human hands, but by the slow, geometric fracturing of the earth itself. Despite the heavy shroud of mystery, it is important to remember that the Bermuda Triangle is one of the busiest shipping lanes in the world. Every single day, massive container ships, luxurious cruise liners, and small private yachts cross these waters without incident. The sheer volume of traffic means that, statistically, accidents are bound to happen. When you have thousands of vessels traversing a region prone to sudden storms and strong currents, the law of averages dictates that some will be lost. It is a bustling highway of commerce and tourism, where the mundane reality of logistics often overshadows the legends. Most sailors who cross the triangle see nothing more than beautiful sunsets, flying fish, and the endless rhythm of the swell. The mystery lies in the exceptions, the rare fractions of a percentage, where the routine turns into the inexplicable. The region is also the historic bowling alley for hurricanes, the great cyclonic storms that churn northward from the equator. Before the age of satellites and radar, a hurricane was a stealth killer. A ship in the 17th or 18th century would have no warning that a storm of apocalyptic power was approaching until the sky turned green and the barometer bottomed out. The floor of the triangle is littered with the bones of Spanish galleons and British warships that were caught in these tempests. These storms are not supernatural. They are the ocean's way of redistributing heat, massive heat engines that spin with terrifying majesty. When a hurricane moves over the triangle, it churns the deep water, bringing cold nutrients to the surface and rearranging the sand below, burying and unburying the wrecks of the past in a constant, violent cycle of hide and seek. Within the shallow banks of the Bahamas, the ocean floor is punctured by deep, vertical caves known as blue holes. These are sinkholes that formed during the ice ages when sea levels were lower and the land was exposed limestone. Rainwater eroded the rock, creating vast cathedral-like caverns. When the ice melted and the oceans rose, these caves were flooded, creating circles of deep, dark blue water amidst the lighter turquoise shallows. Dean's Blue Hole, one of the deepest in the world, plunges down over 600 feet. These holes are not just static pits, they breathe. The tides pump water in and out of the complex tunnel systems, creating powerful vortexes and suction currents at the surface. A small boat or a swimmer caught in this tidal inhalation can be dragged down into the labyrinth of caves, trapped in a beautiful, deadly geological lung that exhales only when the tide turns. The mystery of the witchcraft is a testament to how quickly the ocean can change from a playground to a void. In December 1967, a hotel owner named Dan Barak took his friend out on his cabin cruiser, the Witchcraft, to view the Christmas lights of Miami from the water. They were only a mile offshore. Barak radioed the Coast Guard to report a minor vibration in his propeller and requested a tow, specifically stating that it was not an emergency. The Coast Guard arrived at the location 19 minutes later. The Witchcraft was gone. There was no debris, no life jackets, and no sign of the boat. In 19 minutes, a sturdy, unsinkable cabin cruiser had vanished in calm seas, virtually within sight of the neon glow of the city. The Coast Guard searched hundreds of square miles, but the ocean offered nothing back. It was as if the boat had simply been erased from the surface. At the heart of navigation in the Triangle is the concept of magnetic anomalies, a scientific reality that has bedeviled sailors for centuries. The Earth is surrounded by a magnetic field, a protective bubble generated by the molten iron swirling in the planet's outer core. This field is not uniform. It shifts, wobbles, and fluctuates. The Bermuda Triangle is one of the few places on the globe where the magnetic lines of force flux in complex ways. While we often speak of the agonic line, there are also localized magnetic anomalies, patches of the crust where the magnetic pull is stronger or weaker. For a pilot relying on analog instruments, flying over a magnetic anomaly can cause the compass card to dip or swing, creating a momentary disconnect between the instrument and the reality. It is a reminder that we are navigating on a giant, spinning magnet, and the invisible forces that guide us are as fluid and changeable as the water itself. To understand the invisible forces at play, we must look at the specific tragedies that gave this region its name, such as the haunting disappearance of the SS Marine Sulphur Queen. This vessel was not a fragile wooden boat lost to a storm, but a 523-foot T2 tanker, a fortress of steel converted to carry a cargo as volatile as the ocean itself, molten sulfur. On February 2, 1963, she sailed from Beaumont, Texas, heading for Norfolk, Virginia, carrying over 15,000 tons of liquid sulfur heated to 275 degrees Fahrenheit. As the ship entered the Florida Straits, the crew sent a routine radio message, chatting about personal matters and the weather, which was reported to be rough but manageable. That was the last sound ever heard from the Queen. She vanished into the blue silence. When the Coast Guard launched a massive search, they found only a few life jackets, a foghorn, and a piece of a board bearing the ship's name, drifting in a yellow, sulfuric slick. The mystery lies not just in the sinking, but in the speed of it. For a ship of that size to disappear without a distress call suggests a catastrophe that struck faster than the human hand could reach for a radio. Some theories suggest the sulfur leaked and ignited, creating a massive explosion, while others believe the ship, weakened by the corrosive nature of its cargo, simply broke in two, dragged down by the weight of its own heated heart, before the ocean could even register the splash. The skies above the triangle hold as many ghosts as the water below, and few mysteries are as chilling as the loss of the Star Tiger. This was a Tudor IV aircraft, a luxury airliner owned by British South American Airways, representing the pinnacle of post-war aviation comfort and safety. On January 30th, 1948, the Star Tiger was flying from the Azores to Bermuda, carrying 25 passengers and 6 crew members. The pilot, Captain Brian McMillan, was a highly experienced flyer, and as the plane approached Bermuda in the pre-dawn darkness, he received a weather report confirming strong headwinds, but nothing alarming. The plane requested a radio bearing, received it, and then simply ceased to exist. There was no static, no frantic call for help, and no debris ever found. The investigation that followed concluded with a statement that reads like poetry rather than a technical report, noting that the cause of the accident would likely remain known only to those who were on board. It is as if the plane flew through a doorway in the sky that closed immediately behind it, leaving the world on the other side untouched and unaware. Less than a year later, the sister ship of the Star Tiger, known as the Star Ariel, would suffer an almost identical fate, cementing the legend of the Star airliners. On January 17, 1949, the Star Ariel departed from Bermuda, heading for Kingston, Jamaica, flying in perfect weather. The sky was clear, the sea was calm, and visibility was excellent. The pilot reported his position routinely, stating that he was switching frequencies to contact Kingston. That switch was the final act of the aircraft. The silence that followed was absolute. Unlike the Tiger, which fought headwinds, the Ariel was flying in conditions so perfect that meteorologists later struggled to find a single cloud in the sky that could be blamed. The loss of 2 state-of-the-art aircraft from the same airline in the same region within a year defied statistical probability. The investigations considered sabotage, mechanical failure, and fuel starvation, but without a single rivet of wreckage to examine, the star Ariel became another phantom, a silver bird that dissolved into the bright, blinding light of the tropical sun. Deep within the waters of the Bahamas, cradled by the island of Andros, lies a place that seems designed for secrets, the tongue of the ocean. This is a deep, U-shaped trench that separates the islands of Andros and New Providence, a geological canyon where the floor drops from shallow coral reefs to a depth of 6,000 feet almost instantly. The water here is deep, quiet, and sheltered from ocean noise, making it the perfect acoustic laboratory. It is here that the United States Navy established the Atlantic Underwater Test and Evaluation Center, or AUTEC. Often called the Area 51 of the Atlantic, this facility is used to test submarines, sonar systems, and underwater weapons. The isolation of the tongue means that sound travels with crystal clarity, allowing military scientists to measure the acoustic signature of submarines to the decibel. While the base is a center of science, its presence in the heart of the triangle has fueled endless rumors of recovered spacecraft and underwater anomalies, though the reality is likely a quiet, diligent study of how sound moves through the heavy, pressurized darkness. Within this deep trench and the surrounding waters, the ocean plays tricks with sound using a phenomenon known as the SOFAR channel, or the deep sound channel. This is a horizontal layer of water, typically found at a depth of around 800 to 1,000 meters, where the speed of sound is at its minimum due to the interplay of temperature and pressure. Sound waves that enter this channel become trapped, bouncing back and forth between the warmer water above and the pressurized water below, traveling for thousands of miles without losing energy. A whale singing in the SOFAR channel off the coast of Puerto Rico can be heard by listening devices in Ireland. In the Bermuda Triangle, this channel acts as a global telephone line for the ocean, carrying the groans of shifting tectonic plates, the distant rumble of storms, and the biological clicks of sperm whales. It creates a soundscape that is never truly silent, a hidden highway of noise that connects the triangle to the rest of the planet in ways we cannot see, only hear. The biology of the Sargasso Sea, which overlaps significantly with the triangle, contains one of the greatest migration mysteries in the animal kingdom, the journey of the European eel. These eels begin their lives in the freshwater rivers of Europe, living in dark, muddy banks for decades. But when the urge to breed strikes, they undergo a metamorphosis, their eyes growing larger and their bodies turning silver. They leave the rivers and swim thousands of miles across the Atlantic Ocean, guided by an instinct we still do not fully understand, to reach the Sargasso Sea. Here, in the warm, stagnant waters of the triangle, they spawn and die. The microscopic larvae, shaped like transparent willow leaves, then drift on the currents for years to return to the very rivers their parents left. It is a cycle of life that centers entirely on this specific patch of ocean, a biological pilgrimage where millions of eels converge in the deep, silent waters to ensure the survival of their species, using the triangle as both a graveyard and a nursery. The waters around Bermuda itself are guarded by a ring of coral reefs that have claimed more than 300 ships, earning the island the ancient nickname, the Isle of Devils. Spanish sailors in the 16th century avoided the island, terrified by the shrieking sounds they heard at night. They believed the island was inhabited by demons, but the sounds were actually the calls of the Bermuda petrel, a seabird, and the wild pigs left by previous shipwrecks foraging in the dark. The reefs, however, were a very real danger. Hidden just beneath the surface, these sharp, calcified ridges could tear the bottom out of a wooden hull in seconds. The famous North Rock, a jagged pinnacle that breaks the surface miles from shore, stands as a tombstone for unsuspecting vessels. In the days before lighthouses, a ship could be sailing in deep, safe water one moment and impaled on a coral spire the next, leaving the crew to perish in the surf while the island remained a tantalizing, unreachable shadow on the horizon. One of the most unsettling types of mystery in the Triangle is the ghost ship, and the story of the Ellen Austin is a prime example. In 1881, the American schooner Ellen Austin was sailing west of the Azores when the captain spotted a ship drifting aimlessly. Upon boarding, the crew found the ship in perfect condition, stocked with food and water, but completely abandoned. Seeing a chance for salvage, the captain placed a prize crew on board the derelict vessel to sail it to port. A sudden squall separated the two ships, and when the Ellen Austin regained visual contact days later, the derelict was drifting again. When they boarded it a second time, the prize crew, their own men, had vanished without a trace. The ship was empty once more. The captain, terrified but determined, tried again with a second crew, but the legend says that after another fog rolled in, the ship disappeared for good, taking the second crew with it into the grey oblivion. It is a story of repetition, a stutter in reality, where the ocean claims not just a ship, but the very people sent to save it. The weather in the Triangle includes the formation of waterspouts, which are essentially tornadoes that form over water. These are not the rare, singular events seen on land, but can appear in families, with 3 or 4 spinning columns visible at once. Waterspouts in the Triangle are often fair weather spouts, forming not from supercell thunderstorms, but from growing cumulus clouds in relatively calm conditions. They look like slender, translucent tubes of water reaching up to the sky, dancing on the surface. While beautiful from a distance, they are dangerous to small craft and aircraft. A pilot flying low could be caught in the turbulent vortex of a waterspout that is nearly invisible against the grey rain or the dark sea. These spinning elevators of water act as localized vacuum cleaners, sucking up seawater and spray, creating a hazard that is both mesmerizing and deadly, a pillar of energy connecting the ocean to the clouds. Navigating the shallow waters of the Great Bahama Bank involves crossing a landscape that looks more like a desert than an ocean. The water here is incredibly shallow, often less than 20 feet deep for miles, and the bottom is made of brilliant white calcium carbonate sand. This sand reflects the sunlight, turning the water into a glowing electric turquoise that is so bright it can be blinding. Pilots flying over this region can lose their horizon line because the color of the water blends seamlessly with the color of the sky. This optical illusion is a deadly trap known as spatial disorientation. If a pilot cannot distinguish up from down, they may bank the aircraft into a turn that leads them directly into the water, believing they are climbing into the sky. It is a world without shadows, a landscape of light where the visual cues of the physical world dissolve into a wash of pure, disorienting blue. The geological boundary of the Triangle is marked by the Wall, a dramatic underwater cliff off the coast of islands like Bimini and Andros. A swimmer can be floating in 20 feet of crystal clear water, looking at starfish and conch shells, and then suddenly swim over an edge where the bottom drops away into thousands of feet of indigo darkness. This drop-off is sudden and terrifyingly steep. The water temperature plummets as you cross the line, and the currents shift from the gentle flow of the shallows to the powerful, deep ocean rivers. This transition zone is a place of high biological activity, where large predators like hammerhead sharks patrol the wall, waiting for prey to drift off the shelf. For a diver or a sailor, the wall represents the physical edge of safety, the threshold where the friendly, sunlit Caribbean ends and the indifferent, crushing Atlantic begins. The Carroll A. Deering, a 5-masted schooner found aground off Cape Hatteras in 1921, is technically on the northern fringe of the triangle, but its mystery is deeply woven into the region's lore. The ship was found with its sails set, its galley laid out with food for a meal that was never eaten, and its crew entirely missing. The only living creature on board was a 6-toed cat. The personal effects of the crew were undisturbed, and the navigation equipment was gone. Theories ranged from piracy to mutiny, but the eerie stillness of the scene, the coffee cups on the table, the empty bunks, the ship waiting for men who would never return, has made it a ghost story that sailors still whisper about. It suggests a sudden silent removal, an event that interrupted the most mundane moments of life, leaving the ship as a hollow shell drifting on the tide. We must also consider the phenomenon of clear air turbulence, KT, a weather hazard that is completely invisible to radar and the naked eye. In the complex atmospheric intersection of the triangle, where the warm air of the Gulf Stream meets colder air masses from the north, jet streams can become unstable. A plane flying through a perfectly blue sky can suddenly hit a pocket of turbulent air that drops the aircraft hundreds of feet in a second. This violent shaking can cause structural failure or knock a pilot unconscious if they are not strapped in. Unlike a thunderstorm, which you can see and avoid, clear air turbulence is a phantom force. It is wind shear that waits in the silence, a hidden pothole in the sky that can turn a calm flight into a disaster without a single cloud to warn of its presence. The story of the NC 16001, a Douglas DC-3 airliner, adds a musical note to the mystery. On December 28, 1948, the plane was flying from San Juan, Puerto Rico, to Miami. The pilot, Robert Lindquist, reported that he was 50 miles south of Miami and could see the lights of the city. He radioed for landing instructions, but the transmission was strange. He ended his message by singing the holiday carol, "We Three Kings." The plane never landed. Despite the report of seeing city lights, the aircraft was nowhere near the airport. It is believed that the wind had drifted the plane far off course into the Gulf of Mexico or deep into the Everglades, and the lights he saw were stars reflecting on the water or the distant glow of a completely different town. The singing pilot, joyful and confident, flew his passengers into the darkness, guided by a mirage, vanishing with a song on his lips into the silence of the night. The chemistry of the ocean floor in the triangle may hold the key to some disappearances through the release of methane hydrates. We touched on this, but the physics of a methane blowout deserves deeper contemplation. When high-pressure methane gas escapes from the seabed, it moves upward as a plume of bubbles. As it rises, the gas expands, reducing the density of the water above it. A ship floating on the surface depends on the water displacing its weight. If the water becomes a frothy mix of 50% gas and 50% liquid, the ship suddenly weighs more than the water it is displacing. It creates a hole in the ocean. The ship drops instantly, not sinking, but falling through the water. Once the ship is submerged, the bubbles continue to rise, potentially flooding the engines and suffocating the crew with methane gas. The ocean then closes back up, the bubbles dissipate, and the surface returns to a calm, blue mirror, leaving no trace of the hole that opened just moments before. The Great Isaac K. Lighthouse stands as a lonely sentinel in the Bimini district of the Bahamas, a towering structure that witnessed its own mystery. In 1969, the two keepers of the lighthouse, Ivan Major and B. Mollings, disappeared. The lighthouse was found deserted, with no sign of a struggle or foul play. The station's logbook was left behind, but offered no clues. The island is small, exposed, and desolate, a rock in the middle of the stream. Locals speak of the Grey Lady, a ghost said to haunt the island, but the disappearance of two experienced keepers suggests something more tangible but equally baffling. Perhaps a rogue wave that swept the island, or a sudden storm that dragged them into the sea. The light continued to rotate, casting its beam over an empty island, a machine doing its job long after the humans who tended it had vanished into the blue. The psychological phenomenon known as the leans is a constant threat to pilots in the featureless environment of the triangle. The inner ear, which controls human balance, relies on gravity to tell us which way is down. In a banking turn, centrifugal force can mimic gravity. If a pilot turns the plane slowly enough, the fluid in the inner ear does not register the movement. When the pilot eventually snaps the plane back to level flight, the inner ear feels as though the plane is tilting in the opposite direction. This sensory illusion is overpowering. A pilot will feel with absolute certainty that they are flying crookedly, even when the instruments show they are level. In the dark over the ocean, without a horizon to correct the brain, a pilot may correct the plane based on this feeling, entering a death spiral into the sea while believing they are flying straight and true. The Cotopaxi is a name that haunted the triangle for nearly 100 years. This steamship vanished in 1925 while en route from Charleston to Havana. For decades, it was the archetypal triangle mystery, a ship that sent a distress call reporting a list and water in the hold, and then disappeared. In 2020, the wreckage was finally identified off the coast of St. Augustine, Florida. The discovery proved that the ship didn't vanish into another dimension. It sank due to a storm and poor hatch covers. But the century of silence that lay between the sinking and the discovery speaks to the vastness of the ocean. Even in shallow water, a massive steel ship can hide for 100 years, buried in sand and obscured by time, a reminder that lost does not mean gone, but simply hidden. The ocean currents in the triangle are not just surface rivers. There are also deep countercurrents that flow in the opposite direction thousands of feet below. While the Gulf Stream rushes north at the surface, the deep western boundary current moves cold, dense water south along the ocean floor. This creates a shearing effect in the water column. A submarine or a sinking object passing through these layers experiences different forces, pulling it in different directions. This complex layering of water masses helps to distribute heat around the planet, acting as the Earth's air conditioning system. But for anything lost in the deep, it serves as a chaotic disperser, ensuring that where an object hits the bottom is miles away from where it left the surface. Finally, let us consider the sheer isolation of the night sky over the Bermuda Triangle. Far from the light pollution of the coast, the stars here appear with a brilliance that can be overwhelming. For centuries, sailors used these stars to navigate, measuring the angle of celestial bodies to find their place on the map. But in the triangle, the atmosphere can sometimes play tricks with this light. The refraction of starlight through humid, tropical air layers can cause stars to twinkle violently or even appear to move and change color. This phenomenon, known as scintillation, has likely been the cause of many UFO reports in the region. A bright planet like Venus, hanging low on the horizon and refracting through layers of heat haze, can look like a hovering ship, pulsing with red and green light. The sailor, exhausted and alone in the dark, sees a companion in the sky, not realizing it is just the ancient light of a planet distorted by the thick, breathing air of the ocean. We float now into the stillness of the Horse latitudes, a belt of high pressure that circles the globe at roughly 30 degrees north, cutting directly through the heart of the Bermuda Triangle. This atmospheric phenomenon is the silent engine behind the Sargasso Sea's notorious calm. Here, the warm air from the equator cools and sinks toward the ocean surface, creating a vertical column of suppressing pressure that crushes the wind before it can form. For the sailors of the wooden ship era, this region was a terrifying cage of glass. A ship could enter these waters on a brisk wind, only to have the sails go slack and heavy, trapping the crew in a breathless silence that could last for weeks. The sea surface, undisturbed by even a ripple, would turn into a perfect, relentless mirror, reflecting the intense tropical sun with a blinding glare. It was called the horse latitudes because, as supplies of fresh water dwindled in the heat, desperate sailors were often forced to throw their cargo of horses overboard to conserve the precious liquid for themselves. The ocean here holds the memory of that desperation, a place where the lack of movement was far more deadly than the fiercest storm, and where the silence of the wind meant that no help was coming, no matter how loudly one prayed. Drifting among the golden mats of sargassum weed in this stagnant calm, we find a miniature world that has evolved in total isolation from the shore. The sargassum is not rooted to the ocean floor. It is a holopelagic organism, meaning it lives its entire life cycle floating freely on the surface, kept buoyant by millions of tiny gas-filled bladders that look like grapes. Within this tangled, floating forest, nature has created a masterclass in camouflage. The sargassum fish, a type of frogfish, has evolved to become indistinguishable from the weed itself. Its skin is ragged and mottled with patches of brown, ochre, and yellow, mimicking the texture of the decaying leaves. It possesses prehensile fins that act like hands, allowing it to crawl through the thick vegetation rather than swim. It sits motionless in the canopy, a hidden predator in a drifting jungle, waiting for unsuspecting shrimp or small crabs to wander within range of its ambush. This ecosystem is a raft of life in a nutrient-poor desert, a wandering oasis that supports thousands of specialized creatures that would instantly perish in the open blue water just inches away. The mystery of the Rubicon serves as a haunting reminder of the ghost ships that populate the Triangle's history. In October 1944, this US Navy cargo ship was found drifting off the coast of Florida by a Coast Guard cutter. The ship was in excellent condition, buoyant, and undamaged. But when the boarding party stepped onto the deck, they found a silence that was completely absolute, save for the whining of a single, lonely dog left behind. The crew of over 300 men was gone. The ship's log was missing, as were the lifeboats, yet there was no sign of distress, no battle damage, and no chaotic disarray to suggest a panic. It appeared as though the men had simply ceased to be, leaving the dog as the sole witness to an event that had stripped the ship of its humanity. While later theories suggested a sudden hurricane might have prompted a premature evacuation, leaving the ship to survive while the lifeboats perished, the image of the Rubicon drifting aimlessly with its canine guardian remains a chilling portrait of abandonment in the vastness. Just over a decade later, the mystery would repeat itself with the yacht Connemara IV. In September 1955, this luxury pleasure craft was found adrift roughly 140 miles southeast of Bermuda. The yacht was a picture of resilience. It had survived the passage of Hurricane Ione, a storm that had churned the Atlantic with savage fury. Yet, the crew was missing. The boat was sound, albeit tossed by the seas, but there was no one on board to steer it. This discovery fueled the speculation that the Triangle had a specific appetite for sailors while sparing their vessels. However, the sleepy reality is often more tragic than mysterious. It is likely that the owner, fearing the approaching hurricane, had anchored the boat and evacuated to shore, only for the anchor cable to part in the violence of the storm. The boat, freed from its tether, drifted out to sea, riding the waves alone, a ghost created not by abduction, but by the simple mechanical failure of a chain in the face of nature's overwhelming power. The structural integrity of the massive colliers like the USS Cyclops brings us to the tragedy of her sister ships, the USS Proteus and the USS Nereus. It is a rare and unsettling fact that 3 ships of the same class, all built to carry heavy loads of ore, vanished in the same region of the ocean. The Proteus disappeared in 1941, followed by the Nereus just weeks later. Neither sent a distress call, neither left a trace. While submarines were suspected due to the ongoing World War, German records captured later showed no U-boat operations in those specific areas at those times. The answer likely lies in the chemistry of their cargo. These ships were carrying bauxite and manganese ore, which can be highly corrosive to steel. Over years of service, the acidic dust from the ore may have eaten away at the I-beams that formed the structural spine of the ships. In the heavy, rhythmic pounding of a triangle storm, a weakened spine could snap instantly. A ship as long as a skyscraper could split in half and plunge to the bottom in minutes, taking its radio antennas and its crew down before a hand could reach the telegraph key, a victim of silent, slow-moving rust. Beneath the keel of these passing ships, the water of the Bahamas is the site of a strange chemical phenomenon known as a whiting. Pilots flying over the Great Bahama Bank often report seeing massive, milky white patches of water that look like clouds of smoke billowing from the sea floor. For years, this was thought to be mud stirred up by giant schools of fish or even volcanic activity. We now understand that it is a spontaneous precipitation of calcium carbonate. The water on the banks is supersaturated with dissolved limestone. When the conditions are just right, perhaps a change in temperature or the presence of certain algae, the limestone suddenly crystallizes out of the water, turning the ocean into a vast vat of milk. These events can cover hundreds of square miles, creating a surreal, opaque landscape that blinds divers and confuses satellite imagery, turning the crystal-clear window of the ocean into a frosted pane of glass that hides everything below. The psychological impact of the blue desert cannot be overstated for those navigating the triangle alone. This is a phenomenon known as the break-off, a sensation often reported by deep-sea divers and high-altitude pilots. When surrounded by a uniform, featureless blue, whether it is the water of the Gulf Stream or the sky above it, the human brain loses its ability to orient itself. Without lines of perspective, shadows, or landmarks, the mind becomes untethered. Divers in the deep, clear waters of the triangle describe a sudden, overwhelming feeling of detachment from reality, a vertigo where they can no longer tell if they are floating, falling, or suspended in a void. This mental drift can lead to panic or a trance-like state where safety procedures are forgotten. It is the mind reacting to the sheer, crushing scale of the emptiness, a silence so visually loud that it drowns out the instinct for survival. The weather patterns in the triangle are dominated by the Bermuda High, a semi-permanent high-pressure system that sits over the Atlantic like a giant, invisible mountain of air. This system acts as the steering wheel for hurricanes. When the Bermuda High is strong and expansive, it pushes storms westward, driving them into the Gulf of Mexico or the Florida coast. When it weakens or shifts east, it opens a gate that allows storms to curve harmlessly out to sea. The edges of this high-pressure system also create the trade winds, the steady, reliable breezes that powered the commerce of the New World. But the high is not static. It breathes, expanding and contracting over decades. A ship sailing the triangle is essentially riding the winds generated by the breath of this atmospheric giant, a force that decides the fate of coastlines and the path of destruction for the entire hemisphere. The terrifying speed of rapid cyclogenesis, or the bomb cyclone, is a weather event that haunts the northern edge of the triangle. In winter, cold, dry air masses from the North American continent collide with the warm, moist air of the Gulf Stream. This collision can cause a storm to intensify explosively, with the barometric pressure dropping more than 24 millibars in 24 hours. To a sailor, this means that a calm sea can transform into a chaotic nightmare of 50-foot waves and hurricane-force winds in less than a day. These storms are often not predicted with the same accuracy as tropical hurricanes because they form so quickly. A ship caught in a bomb cyclone faces wind shear and wave patterns that are confused and multi-directional, battering the hull from all sides. It is a blender of atmospheric violence that spins up from nothing, catching vessels in a sudden fury that feels personal and targeted. The wreck of the SS Sapona stands as a concrete tombstone in the shallow waters near Bimini. Built during World War I, when steel was scarce, the Sapona was an experiment in engineering, constructed entirely of ferroconcrete. She was a stone ship designed to float. After the war, she was sold and used as a rum runner's warehouse during Prohibition, a floating liquor store anchored in the safe waters of the Bahamas. But in 1926, a massive hurricane tore her from her moorings and slammed her onto the jagged rocks. The concrete hull cracked, and she has sat there ever since, a broken grey monolith rising from the turquoise water. Today, she is a hollow shell, her iron rebar rusting into the sea, used as target practice for bombers during World War II. The Sapona is a stark reminder that even the most unconventional human ingenuity is no match for the raw power of a triangle storm, eventually becoming just another piece of the reef. The optical phenomenon of the green flash is frequently observed on the calm, flat horizons of the triangle. This is not a legend, but a rare atmospheric event that occurs at the exact moment of sunset or sunrise. As the sun dips below the ocean line, the Earth's atmosphere acts like a prism, separating the sunlight into different colors. The red and orange wavelengths are bent the least and disappear first, while the blue and violet are scattered by the air. For a fraction of a second, the green wavelength is the only one that reaches the observer's eye directly. It appears as a brilliant emerald spark sitting on the water, a silent, fleeting jewel that marks the transition from day to night. For sailors on long, monotonous watches, catching the green flash was considered a sign of good luck, a momentary magic trick performed by the physics of light and air over the endless ocean. Deep in the waters of the triangle, the ocean currents do battle in a way that creates cold core rings. These are massive eddies that spin off from the Gulf Stream, trapping a core of cold, nutrient-rich water inside a ring of warm, fast-moving current. These rings can be hundreds of miles wide and can persist for months, drifting independently through the Atlantic. To a submarine or a sonar operator, a cold core ring is a nightmare of acoustic distortion. The temperature difference between the ring and the surrounding water creates a wall that reflects sonar, making it possible for a submarine to hide inside the ring, effectively invisible to detection from the outside. These rings are ghost islands of water, rotating pockets of different physics that move secretly through the main body of the ocean. The danger of shallow water blackout is a silent killer for the freedivers and spear fishermen who frequent the reefs of the triangle. In the crystal clear water, depth is deceptive. A diver may feel they are only 10 feet down when they are actually at 40. When a diver hyperventilates before descending to hold their breath longer, they lower their body's carbon dioxide levels. This suppresses the urge to breathe, but it does not add more oxygen. As the diver ascends, The drop in water pressure causes the oxygen in their lungs to expand and dilute rapidly, starving the brain. The diver can lose consciousness just feet from the surface, fainting without pain or warning. In the lonely silence of the reef, a blacked-out diver simply drifts away on the tide, a victim of the body's own chemistry and the seductive, confusing clarity of the water. The Great Stirrup. Cay Lighthouse and its surrounding waters hold the story of the Bermuda sloop, a vessel design born from the necessities of this treacherous region. In the 17th and 18th centuries, the merchants and pirates of the Triangle needed ships that were fast enough to outrun the navy, but shallow enough to hide in the dangerous reefs where larger warships could not follow. They developed the Bermuda sloop, a ship made of native cedar which was resistant to rot and incredibly light. These ships were rigged with a massive amount of sail on a raked mast, making them the fastest vessels on the ocean at the time. They were the Formula One cars of the age of sail. But their speed came at a cost. They were fragile and unstable. Many simply capsized in sudden squalls, their oversized sails dragging them down. The floor of the Triangle is littered with the bones of these speedsters, ships that were built to cheat the wind, but often paid the price for their daring design. The mystery of the Southern Districts, a Navy LST landing ship tank converted for commercial cargo, adds to the list of sulfur-related disappearances. In 1954, she vanished off the coast of South Carolina while carrying a load of sulfur. Like the Marine Sulfur Queen, she sent no distress call. The only trace found was a life ring. The Southern Districts was a flat-bottomed ship designed for beach landings, not for the high, rolling waves of the open Atlantic. It is believed that a rhythmic wave pattern caused the ship to hog and sag, bending in the middle until the hull snapped. The sulfur cargo, heavy and shifting, would have hastened the end. It is a reminder that repurposing ships for tasks they were not designed for is a gamble with the ocean, one that the Atlantic rarely allows you to win. We must also acknowledge the dead zones of communication that can occur in the Triangle due to solar activity. The ionosphere, a layer of the Earth's upper atmosphere, reflects radio waves, allowing for long-distance communication. However, during intense solar storms, the sun bombards the Earth with charged particles that can disrupt this layer. In the magnetic anomaly of the Triangle, these disruptions can be amplified. A ship or plane relying on high-frequency, HF radio, might find their radio dead silent, receiving only static hiss for hours. This is not a supernatural silence, but a celestial one. The pilot is shouting into a microphone, but the sky itself is refusing to carry the voice, absorbing the signal into a chaotic soup of solar energy. The bioluminescence in the waters of Puerto Rico's Mosquito Bay, on the edge of the Triangle, offers a glimpse of the living light that has terrified sailors for centuries. This bay contains one of the highest concentrations of dinoflagellates in the world, microscopic plankton that flash blue when disturbed. When a fish swims through this water, it leaves a glowing trail like a comet. A ship cutting through a bloom of these creatures at night creates a bow wave of fire, illuminating the sails and the faces of the crew in a ghostly, green-blue light. For early explorers, seeing the ocean catch fire beneath their hull was a sign of sorcery or impending doom. In reality, it is a defense mechanism, a tiny burglar alarm used by the plankton to startle predators. But on the scale of a ship, it turns the dark ocean into a swirling galaxy of cold stars. The SS Poet, a cargo ship carrying grain to Egypt, vanished in 1980 after leaving Philadelphia. She was a 522-foot veteran of the seas, yet she disappeared without a Mayday call. The search for the Poet was one of the most extensive in modern history, yet not a single life jacket or oil slick was found. The ship simply drove out of the world. Theories range from a sudden rogue wave that capsized her to a structural failure that happened so fast, the air trapped inside the hull didn't even have time to escape before she hit the bottom. The loss of the poet is a modern reminder that even with satellite tracking and advanced radar, a massive steel object can still slip through the cracks of our surveillance, hidden by the sheer vastness of the water. The teal sound, recorded by the hydrophones at UTEC, remains a curious footnote in acoustic oceanography. While monitoring for submarines, analysts have occasionally picked up unidentified, transient sounds that do not match the biological profile of whales or the mechanical signature of engines. These sounds are often low-frequency pulses or sudden, sharp spikes in noise. While likely caused by geological shifting or unknown biological behaviors, perhaps the snapping of giant deep-sea shrimp or the grinding of underwater landslides, they contribute to the eerie feeling that the ocean is speaking a language we have not yet deciphered. In the silence of the listening post, hearing a sound that has no name is a reminder that we are guests in a very old, very deep house. Finally, let us rest our thoughts on the sheer depth of the Puerto Rico Trench, the deepest point in the entire Atlantic Ocean. Known as the Brownson Deep, it plunges to over 27,000 feet. The pressure here is over 800 times greater than at the surface. It is a world of absolute, crushing finality. At the bottom, life exists in slow motion, with amphipods and strange, translucent fish moving through water that is near freezing. If a ship sinks here, it takes hours to fall to the bottom. It descends through layers of darkness, past the twilight zone, past the midnight zone, into the abyss, and finally, into the Hadal zone. It lands in a silence that has been unbroken for millions of years. This trench is the ultimate keeper of secrets, a geological vault that will never give up what falls into its grasp, holding the lost history of the triangle in a cold, dark embrace forever. Moving from the crushing depths of the trench back to the surface, we must acknowledge the historical fury of the Great Hurricane of 1780, a storm so powerful it permanently altered the maritime history of the triangle. Known as San Calixto, this tempest remains the deadliest Atlantic hurricane on record, a swirling engine of destruction that claimed over 22,000 lives. It churned directly through the heart of the Bermuda Triangle, tearing through the Caribbean with wind speeds estimated to have exceeded 200 miles per hour. Sailors of the time described a phenomenon that seems physically impossible. The wind was so intense that it stripped the bark off the trees before snapping the trunks like matchsticks. British and French fleets positioned in the region for the American Revolutionary War were obliterated. Dozens of warships, heavy with cannons and crew, were lifted by the storm surge and smashed against the reefs, or simply capsized in the open ocean. The ocean floor in this region is paved with the iron and oak of that single week in October, a reminder that the triangle has been a graveyard for navies long before the invention of the airplane or the radio. Beneath the surface of these storm-tossed waters lives a phenomenon that baffled early sonar operators and contributed to the lore of phantom bottoms. This is the deep scattering layer, a massive dense cloud of living organisms, mostly lanternfish, krill, and siphonophores, that hangs in the water column. During the day, this living cloud retreats to the darkness of the deep, often hovering around 1,500 to 2,000 feet, where it is safe from predators. But at night, in the greatest migration on Earth, this biomass rises to the surface to feed. In the early days of sonar, ships navigating the triangle would send out sound pulses to map the bottom, only to receive a strong echo from this layer, leading them to believe the water was much shallower than it actually was. Captains would panic, thinking they were about to run aground in the middle of the deep ocean, only for the bottom to vanish or move as the sun rose. It is a biological curtain, a shifting, living floor that hides the true depth of the abyss and creates a false reality for those listening in the dark. The tragedy of the USS Scorpion is a Cold War mystery that rests in the deep waters on the periphery of the region. In May 1968, this nuclear-powered submarine, carrying 99 crewmen, vanished while transiting the Atlantic. For months, the Navy searched in vain, listening to the silence of the ocean. The wreckage was eventually found in over 11,000 feet of water. The acoustic data recorded by underwater listening posts, the same SOSUS arrays used to track Soviet subs, captured the terrifying sound of the submarine imploding. The pressure of the deep ocean crushed the hull in a fraction of a second, a violent event that was registered as a sharp, high-energy acoustic spike, followed by the quiet rain of debris hitting the seafloor. While theories of torpedo malfunctions or enemy attacks swirled, the most likely cause was a runaway hydrogen explosion in the battery well. The Scorpion sits there still, a steel tomb in the eternal dark, its nuclear reactor slowly cooling in the freezing pressure, a monument to the unforgiving nature of the deep. The underwater topography of the Bahamas includes the Great Bahama Canyon, a submarine feature that rivals the Grand Canyon in scale, but is hidden entirely from view. This massive gorge cuts into the submerged limestone platform, with walls that rise vertically for thousands of feet. It is a place of geological violence, where massive underwater landslides occur. A shelf of limestone, weakened by erosion or seismic activity, can suddenly shear off, sending millions of tons of rock and sediment cascading down into the abyss. These turbidity currents travel at highway speeds, destroying everything in their path and snapping underwater cables. If a submarine or a deep-sea submersible were exploring the canyon during such an event, they would be buried instantly. The canyon creates complex currents and eddies that can pull debris down into the earth, ensuring that anything lost within its walls is effectively erased from the ocean floor. The disappearance of the racing yacht Ravonok in 1958 highlights the vulnerability of even the most experienced sailors. The owner, Harvey Conover, was a distinguished yachtsman and a Commodore of the Cruising Club of America. He was not a novice. He knew the sea. Sailing his 44-foot yawl from Key West to Miami, he steered directly into a sudden, ferocious winter storm. The Ravonok was a sturdy, well-built vessel designed to handle rough seas, yet it vanished with Conover and 4 others on board. Despite an exhaustive search by the Coast Guard, the only trace ever found was the yacht's dinghy, washing ashore near Jupiter, Florida. The sea here does not care about expertise or pedigree. A single breaking wave, catching a yacht broadside in the trough of a swell, can roll the vessel over and snap the mast, leaving the crew trapped inside a chaotic, inverted world that quickly fills with water. We must also consider the psychological weight of the doldrums, the area of calm weather within the triangle that has driven sailors to the brink of madness for centuries. In the age of sail, being becalmed was a death sentence. As the ship sat motionless on a glassy, unmoving sea, the heat would become unbearable. The silence was not peaceful, it was oppressive. Sailors would begin to hallucinate, seeing islands that weren't there or hearing voices in the water. This phenomenon, often called calenture, involves a delirium where the sailor sees the sea as green fields and feels an irresistible urge to leap into it. While modern engines have eliminated the physical danger of being becalmed, the psychological isolation of the open ocean remains. A solo sailor or pilot, surrounded by nothing but blue for hours on end, can still fall victim to the mind's desperate attempt to create patterns and meaning where there is only emptiness. The story of the Raifuku Maru, a Japanese freighter, is often cited in the legends of the Triangle for its chilling final message. In April 1925, the ship ran into a heavy storm while carrying a cargo of wheat. As the vessel took on water and began to list, the radio operator tapped out a frantic SOS. The message, interpreted by listeners, allegedly ended with the words, "Danger like dagger now, come quick." This poetic and terrifying phrase captured the public's imagination, suggesting a supernatural threat. However, historical analysis suggests the operator, struggling with English in a moment of panic, was likely trying to say dagger as a metaphor for the wind cutting like a knife. Or perhaps it was a misinterpretation of the Japanese phrase for propeller broken. The ship sank not because of a monster, but because the shifting cargo of wheat unbalanced the hull, causing it to capsize. The dagger was the ocean itself, sharp and cold, claiming the ship in the confusion of the storm. High above the clouds, there is a weather phenomenon that astronauts and high-altitude pilots have observed over the Triangle. Sprites and elves. These are not mythological creatures, but large-scale electrical discharges that occur high in the atmosphere, far above thunderstorms. While lightning strikes down toward the Earth, sprites shoot upward into the edge of space. They appear as massive blood-red jellyfish or columns of light, flashing for just a few milliseconds. Elves are expanding rings of light that can cover hundreds of miles in diameter. For a pilot flying at night, seeing a flash of red light erupting upward from a storm cloud can be deeply unsettling, looking like an explosion or a strange craft. These electrical phantoms are reminders that the atmosphere is a complex, layered circuit, and the storms we see at the surface are connected to energy releases that touch the very edge of the void. The disappearance of the Sylvia L. Ossa in 1976 is another chapter in the Book of Lost Ore Carriers. This 590-foot ship was carrying iron ore from Brazil to Philadelphia. West of Bermuda, she encountered rough weather. The ship did not send a standard distress call. Instead, shore stations heard a brief, static-filled interruption, and then nothing. When search teams scanned the area, they found an oil slick and a piece of nameplate, but the massive hull was gone. Ore carriers are notoriously stiff ships. They do not flex well in heavy seas. If a wave pattern matches the length of the ship, the stress on the keel can be catastrophic. The Sylvia L. Ossa likely suffered a sudden structural failure, breaking in two and plummeting to the bottom so quickly that the air trapped inside would have been compressed instantly, leaving the ocean surface disturbed only by the rising oil and the silence. The phenomenon of the white squall is a dreaded reality for sailors in these tropical waters. Unlike a massive hurricane that gives warning with dropping pressure and dark clouds, a white squall is a sudden, violent windstorm that strikes from a clear sky or from very small, innocent-looking clouds. The name comes from the white foam that the wind whips up on the surface of the water, which is often the only visual warning of storm. Sailor gets before the impact. The wind speed can jump from 5 knots to 60 knots in seconds. A sailboat under full canvas, enjoying a gentle breeze, can be knocked flat, knocked down, in nautical terms, before the crew can release the sheets. The boat fills with water and sinks while the sun is still shining. It is an invisible hammer blow, a reminder that in the Triangle, the air can be just as treacherous as the water. The design of the Tudor IV aircraft, involved in the disappearances of the Star Tiger and Star Ariel, holds a mechanical clue that is often overlooked in favor of mystery. These post-war planes were equipped with cabin heaters that burned raw aviation fuel. They were essentially flying fuel tanks with open flames hidden in the ductwork. The fuel lines ran through the fuselage, and a small leak could fill the unpressurized spaces with explosive vapor. A single spark from a switch or the heater itself could cause a catastrophic mid-air explosion. In the silence of the ocean, such an explosion would scatter debris over miles, and the heavy engines would sink instantly. The lack of wreckage is not proof of abduction, but evidence of the violent, total destruction that a fuel-air explosion can cause, turning a complex machine into confetti in the blink of an eye. Small aircraft, like the Cessna 172 or Piper PA-28, disappear in the triangle with tragic frequency, and the reason is often the fragility of their airframes against the open ocean. A small plane ditching in the water acts very differently from a large airliner. Fixed landing gear can catch a wave like a hook, flipping the plane upside down instantly upon impact. The weight of the engine in the nose pulls the aircraft down rapidly. Unless the pilot manages a perfect stall-speed landing on the crest of a swell, a feat that is nearly impossible in a panic, the plane can sink in less than a minute. For search and rescue teams, a small white plane bobbing in white-capped waves is invisible. It is a speck of dust on a moving blue blanket. The ocean simply absorbs the aluminum shell, hiding it in the vastness before help can ever arrive. The concept of acoustic shadows plays a role in why modern sonar sometimes fails to find these wrecks. The ocean is not a uniform medium. It has layers of different temperatures and salinities. Sound waves, which sonar uses to see, bend as they pass through these layers. If a wreck is sitting in a deep trench or behind a ridge, the sound waves might curve upward before they hit the object, creating a blind spot. A search ship could pass directly over a sunken vessel and see nothing on their screens but empty bottom. The wreck of the Titanic was found in a relatively flat area, but the jagged, canyon-filled floor of the triangle creates millions of these hiding places, acoustic pockets where the physics of sound conspire to keep lost things lost. The loss of the HMS Atalanta in 1880 is a tragedy that predates the modern concept of the triangle, but fits its profile perfectly. She was a training frigate of the British Royal Navy, carrying nearly 300 young sailors and officers. She sailed from Bermuda, bound for England, and vanished. The search was one of the largest of the 19th century, with the Channel Squadron scouring the ocean for months. Sailors at the time reported seeing an overturned hull drifting in the distance, but when they approached, it was gone. The Atalanta was known to be an unstable ship, prone to rolling heavily. It is likely she was caught in a gale and capsized, trapping the hundreds of young men inside her wooden hull as she sank. The loss devastated a generation of naval families, and the lack of closure fed the growing reputation of the Atlantic as a merciless void. The name Bermuda Triangle itself was not born from ancient folklore, but was coined in a moment of literary invention. In 1964, a writer named Vincent Gaddis published an article in Argosy magazine titled "The Deadly Bermuda Triangle." He wove together unrelated disappearances, Flight 19, the Cyclops, the Star Tiger, and drew a line around them, creating a geographic identity for a series of random tragedies. Before this, the area had no specific name. It was just a stretch of the Atlantic. The power of the name lies in our human need for patterns. Once the shape was drawn on the map, every accident within its borders became part of the legend, transforming a busy shipping lane into a mythical zone of danger. The triangle is, in many ways, a creation of language, a container we built to hold our fear of the unknown. The SS Sudovko was a freighter that sailed from New Jersey in 1926, heading for the Panama Canal. She entered the triangle and was never heard from again. She had a crew of 29. The silence of her disappearance is typical of the era before satellite tracking. A ship in the 1920s was a solitary island. If the boiler exploded, or if a rogue wave smashed the bridge, the ship was alone. The Sudafco likely encountered a weather system that overwhelmed her, but the lack of a final message makes her fate a blank page. She is one of the silent losses, ships that simply sailed off the edge of the known world, leaving families to wonder for decades if their loved ones were castaways on a desert island or resting on the ocean floor. The ocean has a voice, a constant background hum known as microbaromes. These are low-frequency sound waves generated by the interaction of wind and waves during storms. These infrasonic signals can travel thousands of miles through the atmosphere and the water. Sensitive equipment in the Bermuda Triangle picks up this constant, throbbing noise. It is the sound of distant violence, the acoustic signature of hurricanes and gales happening over the horizon. For sensitive creatures, and perhaps even for the subconscious of human sailors, this low-frequency vibration creates a sense of unease. It is a feeling of dread that arrives. Before the clouds, a deep, resonant warning that the ocean is churning somewhere in the dark, transmitting its power through the air and sea. The disappearance of the C-124 Globemaster in 1951 adds a military dimension to the list of lost aircraft. This massive transport plane was flying from Florida to England, carrying cargo and passengers. Over the Atlantic, it reported a fire in the cargo crate. The pilot gave a calm report and turned back, initiating a ditching procedure. Ships and planes rushed to the location. They found charred debris and a partially inflated life raft, but no survivors. The fire likely destroyed the control cables or caused the plane to break apart upon hitting the water. The quick dispersal of the wreckage by the Gulf Stream meant that the main fuselage and the men inside were swept away into the deep before they could be recovered. It was a tragedy of mechanical failure and fire, played out in the lonely theater of the open sea. The dangerous hydrodynamics of the blue holes in the Bahamas create a phenomenon known as the sucking tide. During the incoming tide, millions of gallons of water rush into the underwater cave systems to fill the void. This creates a powerful vortex at the surface, a whirlpool that can drag a swimmer or a small boat down into the earth. Divers who have explored these caves tell of currents so strong they feel like a wind tunnel. If you are caught in the intake, you are pulled through narrow limestone passages into the total darkness of the island's foundation. It is a geological trap, a hidden drain in the ocean floor that activates with the rhythm of the moon, claiming anything that drifts too close to the beautiful, deadly blue eye. Finally, we look at the SSVA Fog, a tanker that vanished in 1972. She was carrying benzene and xylene, highly volatile chemicals. She went down off the coast of Texas, technically just outside the classic triangle, but within its sphere of influence. When divers finally found the wreck, they discovered a scene of incredible violence. The ship had not just sunk, it had been blown apart. The steel plating was bent outward, peeling back like the skin of a banana. A spark in the empty cargo tanks had ignited the fumes, turning the entire ship into a bomb. The explosion was so massive, it likely killed the crew instantly and sent the ship to the bottom in seconds. The only trace on the surface was a chemical sheen. It serves as a grim reminder that often the monster in the ocean is not a sea serpent or a magnetic anomaly, but the volatile energy we carry with us, waiting for a single spark to release its fury. The optical illusions of the Bermuda Triangle are not limited to the water. They extend into the air itself through a phenomenon known as Fata Morgana. This complex mirage occurs when a layer of warm air rests on top of a layer of cold air near the ocean surface, creating an atmospheric duct that bends light rays. For a sailor scanning the horizon, this bending light can distort distant objects in terrifying ways. A cargo ship traveling miles away might appear to be floating upside down in the sky, or a low-lying island might stretch vertically to look like a towering cliff or a massive wall. In the days before radar, these mirages were the source of countless legends of phantom lands and ghost ships that vanished when approached. A pilot flying through this optical soup might see a coastline where there is only open water, or a false horizon that masks the true angle of the Earth. It is a trick of physics that turns the atmosphere into a funhouse mirror, blurring the line between the solid world and the shifting air. The mystery of the Rosalie, a French merchant ship found in 1840, stands as one of the earliest and most eerie examples of a derelict vessel in the region. She was discovered drifting in the Sargasso Sea, her sails set, her cargo of wine and fruits perfectly intact, and her hull undamaged. Yet there was not a single human soul on board. The only living occupant was a canary in a cage, chirping in the silence of the empty cabin. The lifeboat was missing, suggesting an orderly evacuation, but there was no indication of why the crew had fled a perfectly sound ship. The Rosalie was not sinking. She was not burning. She was simply empty. The image of the canary singing to an absent audience in the middle of the Atlantic became a symbol of the triangle's strangeness, a story of a ship that survived whatever terror had claimed its masters. We must also look to the skies for the South Atlantic anomaly, a region where the Earth's inner Van Allen radiation belt dips dangerously close to the planet's surface. While centered further south, the effects of this magnetic weakness extend into the flight paths of the triangle. Satellites passing over this region are bombarded with high levels of radiation, often causing their computers to glitch or shut down to protect themselves. For aircraft, this increased radiation can interfere with sensitive avionics and communication gear. Astronauts on the Space Shuttle and the International Space Station have reported laptops crashing and strange flashes of light in their eyes, cosmic rays hitting their retinas, while passing through this zone. It is a Bermuda Triangle of space, a dent in the Earth's magnetic shield that allows the solar wind to reach down and touch the technology we rely on to navigate. Standing lonely in the deep water southwest of Bermuda is the Argus Island Tower, a research platform that was once a listening ear for the ocean. Built by the US Navy on the summit of an extinct underwater volcano, the tower stood on legs that reached down into the abyss. It was designed to study the acoustic properties of the ocean, measuring how sound waves bend and scatter in the deep water. The scientists who lived on Argus Island were isolated from the world, suspended above the waves in a steel box. They recorded the ambient noise of the triangle, the grinding of the tectonic plates, the distant roar of storms, and the biological static of shrimp and whales. The tower itself eventually became a hazard and was demolished. But for years, it stood as a testament to our attempt to decode the language of the ocean, a solitary metal giant straining to hear the secrets of the deep. The 1940 discovery of the schooner Gloria Calita adds another layer to the narrative of abandoned ships. Found drifting in the Gulf of Mexico on the western fringe of the Mystery Zone, her rigging was ragged and her steering gear was smashed. There was no trace of the captain or the crew. The ship had become a ghost, wandering the currents with no hand at the wheel. The logbook was gone, erasing the history of the final days. The condition of the rigging suggested she had weathered a fierce storm, perhaps a sudden squall that washed the men overboard or forced them into a lifeboat that was swallowed by the sea. The Gloria Calita was towed to port, a hollow shell that offered no answers, only the mute testimony of a broken rudder and an empty deck. Beneath the surface at night, the waters of the triangle come alive with a microscopic fireworks display created by ostracods, also known as sea fireflies. These tiny crustaceans possess a unique defense mechanism. When threatened by a predator, they vomit a cloud of bioluminescent chemicals. This sudden burst of light acts as a burglar alarm, illuminating the predator and making it visible to even larger hunters. In the pitch black of the deep ocean, a school of fish disturbing a swarm of ostracods can trigger a cascade of light, a silent explosion of blue sparks that swirls and pulses in the darkness. During World War II, sailors would sometimes see these glowing trails and mistake them for the wake of a torpedo, leading to evasive maneuvers against an enemy that was nothing more than a frightened cloud of plankton. The collision or structural failure involving two KC-135 stratotankers in 1963 is often cited in triangle lore, though the wreckage was found near Bermuda. These massive jets were flying a refueling mission when they vanished. Debris was found floating in two distinct patches, separated by over 160 miles. At first, this separation suggested two simultaneous, unrelated disasters, a statistical impossibility that fueled wild theories. Later analysis suggested a mid-air collision where the wreckage drifted apart on divergent currents, or an old structural flaw that caused both planes to break up in turbulence. The sheer distance between the debris fields highlights the power of the Gulf Stream to deceive investigators. The ocean acts as a chaotic disperser, taking the evidence of a single event and scattering it across the map to make it look like two. The ocean floor is shaped by turbidity currents, which are essentially underwater avalanches of mud and sand. On the steep slopes of the continental shelf and the underwater canyons of the Bahamas, sediment builds up over centuries. A small earthquake or a storm can trigger a collapse, sending millions of tons of sludge rushing down the slope at speeds of up to 60 miles per hour. These currents are powerful enough to snap thick transatlantic telecommunication cables like thread. A submarine or a remotely operated vehicle caught in a turbidity current would be blinded and buried instantly. These events reshape the seabed, covering shipwrecks in thick layers of silt, effectively erasing them from sonar scans and hiding them forever under a blanket of geological debris. The ancient art of wave piloting, used by Polynesian navigators, would be nearly impossible in the confused seas of the Bermuda Triangle. Experienced sailors can usually read the swell of the ocean to determine the direction of land, as islands disrupt the rhythm of the waves. However, in the Triangle, the waves are a chaotic mix of swells generated by distant Atlantic storms, local squalls, and the rapid flow of the Gulf Stream. The waves reflect and refract off the steep underwater walls and the scattered islands, creating a confused sea where the water moves in unpredictable jagged peaks rather than orderly lines. This chaos makes it difficult for a small boat to find a rhythm, leading to structural fatigue and a ride that is violently uncomfortable, wearing down both the vessel and the crew. The psychological impact of the mirror sea in the doldrums extends to a feeling of existential dread. When the ocean is perfectly flat and the sky is perfectly clear, the horizon line can disappear completely. The blue of the water merges with the blue of the sky, creating a seamless sphere of color. Sailors describe a sensation of being suspended in a void, unable to tell where the water ends and the air begins. This lack of visual reference can induce vertigo and a sense of unreality. In this blue chamber, there is no sense of distance or scale. A floating crate might look like a ship on the horizon. A cloud reflection might look like an island. The mind, starved of sensory input, begins to project its own fears onto the canvas of the calm, turning the peaceful silence into a waiting trap. The drift of the magnetic North Pole affects the agonic line, the invisible boundary where compasses read true. This line is not static. It moves westward over time as the Earth's magnetic field fluctuates. In the time of Columbus, the line ran directly through the triangle. Today, it has shifted into the Gulf of Mexico. This means that the compass mystery, reported by sailors in the 19th and 20th centuries, was a specific historical phenomenon. A navigator, using a chart from 1900 to fly in 1980, would find their magnetic calculations dangerously wrong. The triangle is a place where the rules of navigation are rewritten by the slow, churning motion of the planet's molten core, requiring constant updates to the charts to keep sailors from wandering off course. The discovery of the ghost ship high. AIM-6 in 2003 proves that the phenomenon of crewless vessels is not a thing of the past. The Taiwanese fishing boat was found drifting in Australian waters, but the mystery mirrors those of the triangle perfectly. The ship was in good condition, with fuel in the tanks and fish in the hold, but the captain and engineer were missing. It serves as a modern analogue to the Mary Celeste or the Rosalie. In the triangle, piracy and drug smuggling are often the grim reality behind these modern disappearances. A boat found drifting might not be a victim of a sea monster, but of a hostile boarding where the crew was removed and the vessel left to confuse the authorities. The silence of the ship is not supernatural, but criminal. A crime scene washed clean by the salt spray. Deep in the cold waters, far below the reach of the sun, grow vast forests of Lophelia pertusa, a species of cold water coral. Unlike tropical reefs that need sunlight, these corals feed on organic matter drifting down from above. They build massive, intricate limestone structures in the pitch black, forming reefs that can be thousands of years old. These deep reefs are fragile and slow-growing, expanding only a few millimeters a year. They provide a habitat for strange deep-sea fish and crabs. A ship sinking in the triangle might land on one of these ancient, hidden cities of coral, crushing a structure that has been growing quietly in the dark since the Roman Empire. The bottom of the ocean is not dead. It is a fragile, slow-motion garden that we rarely see. The sound of a hurricane moving over the ocean is deafening to marine life. While we hear the wind howling above the waves, underwater, the noise of the breaking waves and the churning turbulence creates a roar that saturates the ocean with sound. For whales and dolphins that rely on sonar to navigate, a hurricane is an acoustic blinding. They cannot communicate or find food amidst the white noise. This sensory overload may explain why marine animals sometimes beach themselves before or after storms. They are fleeing the deafening cacophony of the triangle's weather, seeking quiet in the shallow waters, only to become trapped by the tide. We must also consider the mundane but tragic reality of insurance fraud as a source of mystery. Throughout history, the triangle has been a convenient place for a ship to vanish. An unscrupulous owner, facing financial ruin, might order a captain to scuttle an old, unprofitable vessel in deep water to collect the insurance payout. The crew is picked up by a Confederate boat, or in darker cases, goes down with the ship. The mystery of the Bermuda Triangle provides a perfect cover story. If a ship sinks in the North Sea, questions are asked. If it sinks in the triangle, the world simply shrugs and adds it to the legend. The depths of the ocean hide the evidence of open seacocks and deliberate sabotage, burying the crime in the same silence that holds the natural tragedies. The ecosystem of the floating sargassum mats serves as a nursery for young sea turtles. After hatching on the beaches of Florida and the Caribbean, baby loggerhead and green turtles swim frantically into the open ocean. They seek out the sargassum weed, using it as a life raft in a grocery store. Their shells are dark brown and bumpy, perfectly mimicking the texture of the seaweed. They spend their lost years drifting in the triangle, hidden in the golden vegetation, eating small shrimp and jellyfish. If the sargassum did not exist, these populations would collapse, The Sea of Lost Ships is actually a cradle of life, a floating incubator that protects the most vulnerable creatures of the ocean until they are large enough to survive the open blue. The blue holes of the Bahamas contain layers of toxic chemistry that preserve the past. At a certain depth in these caves, the fresh water from the rain meets the salt water from the ocean, creating a halocline. Below this, bacterial decay consumes all the oxygen and produces hydrogen sulfide, a gas that smells like rotten eggs and is deadly to breathe. This gas layer, however, creates a anoxic environment that stops decomposition. Divers have found the fossils of crocodiles, tortoises, and even the bones of the indigenous Lucayan people perfectly preserved in the sludge at the bottom. These caves are time capsules, holding the biological history of the islands in a poisonous, silent vault that kills anything that lingers too long, but keeps its body forever. The disappearance of the city of Glasgow in 1854 remains one of the largest losses of life in the maritime history of the Atlantic. This steamship, carrying 480 passengers and crew, left Liverpool for Philadelphia and vanished. While technically in the North Atlantic, her route took her through the ice fields that drift down into the northern edges of the shipping lanes. The mystery of her loss highlights the danger of icebergs in the pre-radar era. A ship traveling at night in fog could strike a berg and sink in minutes. The city of Glasgow left no trace, no survivors, and no message. She simply sailed into the grey mist and did not come out. A reminder that the ocean is a wilderness where hundreds of people can disappear without the world knowing why. The Gulf Stream is not just a river of water. It is a thermodynamic engine that regulates the climate of the Northern Hemisphere. It carries a staggering amount of heat energy, more than 100 times the world's energy demand, from the tropics toward the pole. As this warm water flows through the triangle, it evaporates, pumping moisture and energy into the atmosphere. This energy fuels the storms, the clouds, and the winds. The triangle is the boiler room of the Atlantic weather system. The mysteries of the weather here, the sudden microbursts, the rapid storms, are the result of this massive transfer of heat. The ocean is sweating energy into the sky, creating a turbulent, chaotic atmosphere. That is the direct result of the planet trying to balance its temperature. Finally, we come to rest on the ultimate truth of the Bermuda Triangle, the indifference of nature. The ocean does not keep secrets. It simply keeps water. It is a place of biology, geology, and physics, operating on a scale that dwarfs human endeavor. The ships and planes that lie on the bottom are not captives of a supernatural force. They are simply materials returned to the earth. The iron rusts into the sediment. The aluminum dissolves in the salt. The wood is consumed by worms. The silence of the triangle is not a silence of malice, but of peace. It is the quiet of a world that was here long before us and will be here long after us, shifting its sands, circulating its currents, and breathing its tides in a rhythm that has no need for human understanding. As we drift away from the deep blue waters and the golden weeds of the Sargasso, we leave the mysteries behind, dissolved in the vastness of the Atlantic. The ocean is a place of wonder, where the light plays tricks and the depths hold memories. But it is also a place of profound rest. The waves will continue to roll, the stars will continue to wheel overhead, and the silence will continue to hold the history of all who have passed this way. If you enjoyed this voyage into the deep and the mysterious, I invite you to leave a like, subscribe to the channel, and share your thoughts in the comments below. It helps this little vessel of curiosity find its way to other sleepy travelers. But for now, let the current carry you. Let the horizon fade. You are safe. You are drifting. Good night.